Hi, in this video, we will discuss about bubble sort technique. Sorting is a technique which arranges elements of an array or a list into an order. The most frequently used orders are numerical order and lexicographical order and either ascending or descending. Efficient sorting is important for optimizing the efficiency of other algorithms such as searching. Those require input data to be in a sorted list. Now we will take the first sorting technique, bubble sort. Bubble sort. Okay, so we will discuss this one by taking an array of size 5. So that means we are taking an array of 5 elements and we will discuss how to sort those elements into an order, into ascending order. Okay, so now take the array elements as a example 9, 5, 3, 7, 2. So we're taking array of size 5. Uh, as we all know, our array index starts from 0 and which ends with n minus 1. So at the 0th index we have 9, first index we have 5, second index we have 3, next 7, last one is 2. In bubble sort technique, we have to compare adjacent elements starting from the 0th index. So that is, we are comparing the element which is present at the 0th index with the element which is present at the first element. If 0th position element is less than the element which is present at first position, there is no need to do any swapping. If the 0th position element is greater than the element which is present at first position, then we have to swap those two. And so on. This is to be continued until the last position. So observe this one. First, step 1. So here we are starting from 0th position and we are comparing the element which is present at first position. So at 0th position we have 9 and at first position we have 5. 9 is greater than 5. So that means we have to swap these two elements because we are arranging this thing in ascending order. So that is after comparing those two, 5, 9, after swapping those two, we got this one. So there is no change in the remaining part of the array. So comparison of 0th position element with first position is completed. Next, we have to compare the element which is present at first position with the element which is present at second position. So here, first position element is 9, second position element is 3, 9 is greater than 3. So we are going to arrange our data in ascending order. So that's why we need to swap those two elements. So that is after swapping 5, 3, 9, 7, 2 we will get. Next, we have to compare the element which is present at second position with the element which is present at the third position. Here also 9 is greater than 7. So swap those two elements. After swapping, you'll get 5, 3, 7, 9, 2. So now we have to compare the element which is present at the third position and the element which is present at the n minus 1 position, that is 4. So after swapping, that is 9 is greater than 2, we need to swap. After swapping, what will get? 5, 3, 7, 2, 9. So no more elements are left out. That is, we consider up to n minus 1 position. No more elements are left out. So we have to conclude our step 1 at this point. The end of the step 1, what we observe, the highest element, the maximum element reached its position. That is the last maximum element present in last position. Okay, so that is the output. That is the output of step 1. Okay, so once it reached that 9 is reached its required position, maximum element reached its required position, there is no need to consider that element for further steps. Okay, now we'll start our step 2 in bubble sort algorithm. Step 2 also we have to proceed with the same logic, and we have to start from 0th position. So in 0th position, what we have? 5. In first position, what we have? 3. So here 0th position element is greater than first position element. So we need to swap those two. So 3, 5, 7, 2, 9 after swapping. So 0th element and first element is over. Next, we have to take first element with second element. 5, our first position element is 5. Second position element is 7. 5 is greater than 7 is wrong. So there is no need to swap those two because we are arranging our data in ascending order. So always we are supposed to keep lesser one in left position, greater one in right position. That's why there is no need to swap that particular element, those two elements. So next, second position element, we have to compare with the third position element. So here 7 is greater than 2. So we need to swap those two. That is 3, 5, 2, 7, 9. So we can stop our process here because already we got 9 to the required position. So we can stop our step 2 here. So at the end of step 2, what we observe here, the required element reaches to last but one position. That is a second highest element reached to its position, which is nothing but last but one position. So this is the end of step 2. Now come to step 3. Here also we have to start from 0th position. So 0th position element we have to compare with the first position element. At the 0th position we have 3 and at first position we have 5. 3 is greater than 5 is wrong. So there is no need to swap those two. So 3, 5, 2, 7, 9. Okay, so comparison of 0th position element and first position is completed. Now we have to compare first position element with second position element. So here first position element is 5. 5 we are comparing with 2. 5 is greater than 2. So that is correct. We can swap those two elements. So that is 3, 2, 5, 7, 9. So by observing this one, 5 reached to its required position. So that is there is no need to check 7 and 9 because those elements already reached their required position. So there is no need to take further comparisons with those 7 and 9. So that is end of step 3. Coming to step 4. So what we have to perform? Again, we have to start from the 0th position. So we have to compare 0th position element with the first position element. So 3 is greater than 2. That is correct. So we have to swap those two elements. That is 2, 3, 5, 7, 9. So by considering this one, 3 reached to its required position. Already 5, 7, 9 are present their uh, required positions. So there is no need to continue our step 4. So that is end of step 4. 3 reached to its required position. Now what is the element left out? Only 2 is left out. That is present in its position. So that is end of bubble sort. We have to perform like this. Okay. So in bubble sort, main thing is adjacent elements we have to compare. If left side one is greater than the right side one, we have to swap those two. That is 0th position element is greater than first position element. We have to swap those two. First position element is greater than second position element. We have to swap those two. Like that, we have to continue this process. So here, finally, what we can observe is if array size is if array size, okay, now algorithm, we are taking array size as 5, okay. So take array size is n, then number of steps we performed is n minus 1. So in our previous example, what is the size we have taken? We have taken size as 5. How many steps we performed? We performed 4 steps. So like that, we can perform our bubble sort technique to arrange the elements in ascending order. Okay. So in the case of ascending order, we are considering greater than. Okay, so left size element, that is 0th position element, is greater than first position. We are swapping those two. So by considering this, what we are getting, elements in ascending order. We are getting elements in ascending order. If you use less than, okay, if you take other condition less than, then you are swapping. In that case, what you will get? You will get elements in descending order. So which comparison, which one we are considering? Depending on that one, can get either ascending order or descending order. Now we will take a program for this particular bubble sort. Okay, so here to take this bubble sort program, I will use an online compiler. So here in this compiler, I will give the program and type and explain how to take program for bubble sort technique. So here I am taking array. So a of 100. So n is a size, okay, required size, how much size you want to take, and two loop variables. Because to perform this one, we require two loop variables, two nested loops we require. So two loop variables we consider. Next, at every step, so if left side element is greater than right side one, we are swapping that one. So to perform swapping, I use some third variable, consider that one as a t. So first we have to take size of the array. Size of array. Size of array. So here, so I'm reading this size of array. So percentage d ampersand n. So after taking size of array, now we will read elements of array. Elements of array. So to read array elements, we require one iteration statement. So I'm taking for loop. So here we're reading the array elements. Ampersand a of I, where I is our loop variable. So now to take this bubble sort algorithm, so we are required to use nested loop. So here in the outer loop, so at every step, so this outer loop refers to the our number of steps we are going to perform. That is I is equal to 0, and I less than n minus 1. Okay, that is a if array size is 5, we are performing 4 steps. Array size is 10, we are performing 9 steps. So we are starting from 0, 0 to 3 is 4 steps. So like that, we are number of steps. To take the number of steps, we are taking the outer loop. So next thing is to perform our actual operation. I am taking this inner loop. So here in every step, we are starting from 0th position. And in the first case, in the first step, we are going to up to n minus 1 position. In the second step, we are going to up to n minus 2 position only. In the third step, we are going to up to n minus 3 position. So step by step, so number of comparisons are decreasing. That is a required elements are reaching to their position. We are not considering those things for next comparisons. For that purpose, we are taking n minus I minus 1. So by giving this one, I value always increases. Initially, first case, I value is 0. So we are comparing that one n minus 1. J is less than n minus 1. Later, I value becomes 1. We are comparing j is less than n minus 2. So here what we are doing, what we have to do here, we have to compare element with its next element. If that element is greater than its next element, what we need to perform, we need to swap those two elements. So t is equal to a of j, a of j equal to a of, so j plus 1, which is a swapping technique by using a third variable. We are performing this one. So we swap those two variable. That condition is satisfied. Like this one is complete. This one is to be carried out n minus 1 steps. Okay. So in every step, if that particular condition is satisfied, we are swapping those elements. So after that, we have to print the sorted array. We have to print the sorted array. So to print these arrays, we need to use one iteration statement. So in these cases, we have to start from 0 because array index starts from 0 and array index ends with n minus 1. That's why condition we have taken as n, I less than n. So like that, we can complete our program. So here, what we have taken here, first declaration part, later we are reading the data, size of the array and the elements we are reading. So later sorting technique, how to perform this particular sorting, and later after performing sorting, we are printing our data. So executing size of the array 5. Okay, then we have to enter elements of array. So 9, 5, 3, 7, 2. So after that, we got this sorted array. So what is the main thing in this bubble sort algorithm is whenever this left side element is greater than right side, its next element, we have to swap those. So in every step, we're performing that particular thing. So in every step, required element in the first step, n-1 element we got. Second step, n-2 elements are got. So like bubbles are coming, if you heat the water, bubbles are coming, these elements are coming out. These are maximum elements are coming out in the case of this particular ascending order. Got it? So now what is the complexity of this particular bubble search? So here we used a loop within the loop, two nested loops, one loop within the loop we used. So complexity of this particular bubble sort algorithm is big O of n squared. So with this, we are concluding this particular bubble search.